Assalamu alaikum. Here is another question on erratic motion. We have the AT graph of a train and we want to draw the VT and ST graphs. Also, the question says if the train starts from 0, determine the elapsed time t prime, so this time here, before it comes to again to rest. So at this time, the trains stop. Finally, find the total distance traveled during this time interval. So what was the total distance traveled during this time interval? Okay, they give us the functions for the two segments of the curve. So for the first one here, I can simply a equal 0.1 t, and we can find the velocity function by equating this to dv over dt. Okay, so we'll have the integration of dv is equal the integration of 0.1 t dt, and the limits for the integral is from 0 to v, and for the time is from 0 to time, any time. Okay, so let us carry out this simple integral. We will have v equals 0.1 divided by 2, which is 0.05 t square. Okay, so that's my first v. I can also find the s function, the position function, right? I can say this also now equals to ds over dt, right? So 0.05 t squared, right, times dt equals ds. And the same, we'll do the same. We will integrate both sides from 0 to t and from 0 to s. So now once we do this, also simple integral, we will have s to be 0.05 over 3 t cubed, right? So that will be something like 1 over 60 t cubed. Okay, so that's for this. So these are the velocity and s functions for the first interval, for when a is 0.1. Now for the second interval, when we have a equals negative 1 over 15 time plus 5. Okay, so now we'll find also the velocity. We'll have the integration of dv from 0, or now let us hold on a second, right? Now the velocity at here is no longer 0, right? The starting point at this point. Let us see what will be that. Okay, equals. So we have dv over dt equal this, right? So equals the integration of this function, negative 1 over 15 t plus 5 dt. Okay, now we'll integrate from some point here to v, because I want to find the function, and here from some time, to any time within the second interval. Okay, now to find what will be the velocity here at this point at v, what we can do now, I can go back to this equation, right, and replace the time by 30. So now I want to find the velocity here, and I already found this function or this curve. So I can say now the velocity at 30 seconds is simply 0.05 times 30 squared. So I'm simply replacing here. Okay, so I'll do this, and here the answer is 0.05 times 30 squared. I got 45 meter per second. Okay, so that's the velocity here. So now that's my That's my lower limit of the integral for the v. And for the time, of course, we are doing this from 30, okay, because that's the time here. Okay, now let us evaluate this. I'll have v minus 30, okay. I mean, sorry, the v minus 45, right? So we have found the velocity to be 45. This would be 45. I confused this with the time, so this 45. So v minus 45 equals minus 1 over 15t. So the integration of this will be minus 1 over 30 t squared. Okay. Then we have plus 5t. Okay. And now this is the first. If I replace the upper limit of the integral, right, I'll get the same expression. So now let me immediately replace the lower limits. So now this one here minus the lower limit, minus 1 over 30 times 30 squared plus 5 times 30. Let me simplify now. What I will have, I'll take this to the other side, right, and do some simplification. I got this expression, v to be minus t squared over 30 plus 5t minus 75. So that's the velocity for the second segment. Okay. I can also find the s function now as well by integrating this. So this time now I'm going to find the ds equals this, right, times dt. So equals minus t squared over 30 plus 5t minus 75 dt. Okay, and we will integrate both sides. So equal integration of both sides. Right. Now for the s here, we need to know what are the limits for the s, and the same here. I'm going to use this, right, to find what is s starting from this point, right, because that's my second segment. I mean, that's my second part of the curve. So now I'm going to replace s at 30. I'll get 1 over 60 times 30 cube. I'm replacing in this function. Okay. Okay, so now that will be I got 450 meter. So for the s, I'm doing the integration from 450 to just any s within the interval. Okay, and for the time, clearly we are doing it from 30 to t. So from 30 to t. Okay, I did this integration earlier, and let me give you the results. I got s here to be, it's a very simple integral, minus t cube over 30 plus 5 over 2 t squared minus 75t, right, plus 750. Okay, so that's my s function. Okay, let me here free some space so that I can now make the graphs. Okay, but you know what, before we do the graphs now here, the question asked about finding this, right, finding the elapsed time. What is the elapsed time here? And you know what, we know the following, that at this time the train is going to stop, right, per the question, and I have this function. So now I can find this time immediately by observing this. I can say now, you know, at t prime, the velocity at t prime is equal 0 per the question. So now I'll solve for this minus t prime square over 30 plus 5t, okay, minus 75 equals 0. And let me solve for the time here. I can use the calculator to have a quick answer. I got two solutions, 133.1 seconds and 16.91 seconds. Now, if you think about that, one of the solution need to be, we need to consider only one solution, because now, if you think about that, we are already at 75 seconds, right? So this solution here doesn't make sense. So now I'm going to choose this one, because now I'm already past this time. So now that's the time when the train will stop again. So the t prime simply is 133.1 seconds, right? So we have found the time. What else we can find now? So the question wants us to find the total distance, right? The total distance traveled during this time interval. Since I'm having the s function for this part here, right? And now I have determined just the time. I have found the time now. If I replace this time here in this function, I'll get the distance traveled from this whole interval. So now if I do this now, let me just do this, replace the time in the s function by 133.1, right? So replacing that here, okay? So I got 8,857 meters. So that's the total distance the train traveled. Of course, it's a very fast train. Okay, now let us construct or build the VT and ST graphs, right, using the information we have just obtained. Let me free some space. Okay, I'm just going to keep the results here. So let me remove these calculations and just keep the results. Okay, so I need also to remove these as well. Okay, now let us do first the VT graph. So I have the VT graph, VT. The first portion of the curve, or the first segment here for the velocity, is simply a quadratic function in the velocity, right? So now we know the quadratic function looks something like this, right? It's a positive, so it looks something like that. And of course we talk about the positive part of this, so now I have simply something like this. Okay, so that's for the VT curve for the first segment. Now the second segment is a little bit more complicated. It looks something like that, right? And now here, what do we have? For the second part, I have, t, but still it's a quadratic function, right? But now we have a negative sign before the square power, right? So now it means now this curve will be somewhat concave down, right? And now we know that at some time here I'm going to stop, right? So now that's my time here was 30, and at some time here I know that at 133.1 we have determined that the velocity or the speed will be 0. So now, since this curve is a quadratic curve here, I am going now to draw the quadratic curve, which is something like this, but now I'm going to come to a stop here. Okay, so that's the VT curve. Now, of course, where maybe someone will ask where the 75, the 75 will be somewhere here. That is the 75 seconds. Okay, course, you know, we can also find these velocities at the given time here and so on. Okay, second, now we have to do the ST curve. So for the ST curve, S and T, okay, I have now a cubic function. So for the first portion, it's a cubic function, and for the second one also it's a cubic function. Now the difference is just the sign. You know, of course we have other bunch of terms here, but the leading power here is positive. And let me remind you how the quadratic function looks like. I mean the cubic function. It looks something like this, right? Okay, not really that, a little bit something like this, somewhat, okay. And now if we have a negative power before, if you have a negative sign before the leading power, now this curve will be reflected on the x-axis, right? طيب, now for the first segment here, I'm simply having something like this for displacement. I'll have maybe something like that. Okay, now for the second part here, see, I have the negative power before the leading term, so now I'm going to have something like this. Okay, and you know, that's the time here, that's the time of 30, and that's the end here at 133.1. okay, and here somewhere is the 75 seconds. Okay, now I had a question before, why don't we, you know, close this this curve here why don't the end point of this curve crosses the t-axis? You know, let me try to explain this from the physical point of view, because you know we have traveled some distance, right? So at 133, the distance is not zero. We have already moved, you know, some distance, right? So that's why it's not zero. You know, if we are here, you know, if this curve crosses this axis, it means at that time we had, you know, goes back maybe to zero, but that's not the case, right? We have found that the distance traveled during this time interval was, you know, about almost 9 kilometers. Okay, a little bit less than that. Okay, so that's it for this video. Please like and share if you found these videos useful, and let us know in the comments if you have any questions or suggestions. Thank you very much, and wishing you good luck.